is I've started recording. So what I'm going to do, let me just go through today's session and then where we left, and then for those who will join late, I think they'll follow from the recording. And then after this, you can show me what you did. Is that okay? Okay. So last time when we left when we were supposed to do operators, but I just want to go through this. What we did, just a quick recap, we did variables and data types last time, and we were supposed to start on operators. And I remember saying that a variable is like a container, and whatever is in that container is what we call data. And as we know, a container may maybe contain different types of items, or maybe, the content varies. And that is why we have different types of data. So that brings us to data types. And then once you have a container, once you have a container with some data in it, you may want to do operations like, add the contents, multiply, things like that. So that brings us to operators. And what we're going to do today is like, let's say we want to prepare a meal. And in that meal, we're going to have containers that have ingredients. And then we're going to have operators that we're going to try to assume that when you add maybe different types of maybe flavors and all that, we're going to call that maybe addition. And then maybe when, the different operations that we have, whether arithmetic, whether logical, and so on. So we're going to look at how that works with data and variables. But just to put it all together, when I say variable, think of a container. And when I say data, think of whatever is contained in that particular container, which we're calling a variable. So like I said, if you look at this picture, you see different types of boxes, and inside we have items. So we have the container here, which contains maybe items to do with age. So we have age, and what is stored in age, that particular container is 12. We have a string here as a data type, and the value gems. And the container now is the name, and what is stored there is gems. Same too, we have height. The data type here is a decimal or floating point number stored in that container called height. And like I said, data types, what goes inside the container? Now we have bigger containers which can contain more than one thing. We call them collections. From our last class, I explained this in depth. So we have different types of collections. We have lists, we have tuple, good for defining coordinates. We have sets. These ones make sure there is no repetition or cleans your data, so to remove duplicates. And then we have a well-structured data type which has key value pairs. This is called dictionaries. And when you'll be building serious systems, this will come in handy. And now that brings us to what we're supposed to do today, which is operators. So think of these operators as tools for doing things. So I have my data within the containers, but now I want to manipulate the data. I want to multiply, I want to add, I want to divide, I want to find the modulus or remainder. I want to do a number of things. So think of it that way. So think of it as a tool that allows you to, or tools that allow you to do things with your data. So if you have interacted with a laptop before, or let's say your phone, everybody has a phone. Now, when you power on your phone for the first time, Normally, as you get the first screen that shows you maybe the logo for that particular brand and all that, and then the part that I'm interested in is when now you are able to access your phone or your laptop, and you can actually load WhatsApp, and it opens, and you're able to even chat a few people, send a few messages, and all that. Now, if you bring that into the context of programming, that is how things work. Picture yourself maybe in a room with shelves. Now, in that room, you have shelves which are numbered, let's say 1 to 10. And when you open each shelf as a drawer, or maybe each shelf as a number of drawers. Now, in each drawer, you have maybe things stored, or maybe the way posters work, where everybody has a box. And in each box, there is an item that is stored. Now, let's bring that into the context of computing and this thing of coding and programming. Normally, the reason why you are seeing this file that I'm presenting right now is because, like I'm saying, in shelves, there are locations or compartments where you store your items. The same way a computer was designed. It's like nothing is new that we see in tech. Everything that you see in real world was translated into a computer system. And so somebody sat down and decided, what if I could give a computer a memory with memory addresses or compartments where data can be stored? And the bigger your memory, the bigger the capability to store and maybe keep a bunch of items at once. But the smaller it is, the more you are limited to the number of items you can load. But that is not all, because the entry point to a computer is the RAM, what we call random access memory, if you've heard of that. And the reason why we are calling it random, because it is not permanent storage. It is just storage for you to load your applications first, do your work, and then when you're done doing your work in whatever application you've loaded, like right now, I have this document, so I can edit, add something, or remove something. Now, once I'm done doing whatever I'm doing, I would want to keep that data for next time, right? So what I'm going to do is I'm going to save. Now, when I save that particular file or data that I was working on, is like now you securing a storage space somewhere within a building, or maybe you have a poster box. Once you assign that, you put your items there, and then you're given a special type of key that can, or maybe a combination, if it is a safe, that can make sure that you safely lock your item inside that particular compartment or safe. So when I save my data, it's like for the first time when I loaded it into the RAM, that was to access it and be able to make modifications. But when I save it, we have something we call ROM. And maybe somebody can tell me what normally most people call it internal storage. What do you think ROM means in full? If RAM means random access memory, what about ROM? Can I get a trial? Exactly. So RAM is a read-only memory. What I'm saying is you cannot, if it is read-only, it means you cannot, it cannot allow you to edit anything directly. Anything that is saved. You normally think that when you open a file that you saved in, maybe file, we call it maybe your partitions, your computer partition. So you have partition D or partition A or C, whatever. You normally think that if you save a file there, maybe test.docs or maybe a movie, something like that. And when you load that document and you edit it, you feel like maybe it is loaded from your hard disk or your internal storage. No, you're very mistaken. It is like saying that if you have a safe, you can be able to, and you have a safe and you've locked it. Maybe you've locked an item in it. It's like saying you are able to retrieve that item and do anything with it without opening the safe. Is that possible? So let's let's assume an open safe is a RAM, because the RAM allows you to load your item and maybe make changes. But when you put it back and lock the safe, that is now what we're calling ROM, read-only memory. At that particular point, the only thing you can do is your item is there. But if you want to access it and make changes or look at it or do something with it, you have to open the safe and retrieve the item. That is how the computers also work. And that is how what we are going to discuss today, that is how I'm going to show you how it relates to what we are going to discuss today about data and data types and variables. So when you open a Word document from maybe where it is saved, maybe D or partition or whatever, or even when you're using a phone, you open a file. Normally, it's like opening a safe and telling it that now retrieve my item. I want to do something with it. And then it loads into your RAM again. From your RAM, you can do whatever you want with it. When you're done and you close it or you save it, it's back to being locked to the read-only memory. And that's why we call it ROM. Now, let's bring that into the context of what we're doing today. So I'm saying that you are going to be declaring variables. And I said this variable sits within, the variable is a container. And a container contains some content. And the content is what we're calling data. And that data has different variations. And that's why we're calling them data types. So let's say when you declare a variable and assign a value to it, what you're actually doing is accessing a memory address in your random access memory, and then putting a variable, maybe let's say a value like 5 with a name, so that your computer knows how to retrieve your item. So if you say print A, it actually goes to the memory address, that safe where A is stored, and looks for the value of A, reads that value, and outputs it for you. Whether it is on the terminal, or whether it is on the browser, or whether it is what you're seeing here, it goes through the same process. So I wanted to bring that into today's context, because now if you have different items stored in different memory locations, and you want to do an operation with them, our end goal is, can we build something that can actually manipulate or give our computer instructions to make life easier? You want to build systems. You've been using apps. Banks have built apps that you're using to make your work easier. So these days we have mobile banking. You don't have to queue in the bank to do something. They started from defining variables. And believe you me, in that app that you're using, there are a lot of variables that have been defined. And there are a lot of operations that go on when you actually click a button in your app, or when you actually type your name in the email address box. And if you did the assignment that I gave you guys in our last class, you'll realize that you can actually pick user input and do something with it. The same way when you type your email and password in the browser, you have some boxes where you do that. When you click on login, that data is picked, and a computer is given instructions to do something with that data. But can we start from somewhere, step by step, and build to a point where we can actually build complex systems like that? So what I want to look at today is, how do we manipulate this data that we've already defined? So that brings us to this is day 4. I don't know. So let's call it day 4. Did we ever have, yeah, we had day 3. So let's say day 4.py. And what I want to talk about today is variables, data types, and basic operations in Python. So let's start with variables. So let's declare a variable. And when I say declare a variable, is like define a container name. Just like I can say, like what I was related to what I was saying, when you have different lockers and the lockers are numbered, maybe A, B, C, or blah, blah, so that it is easy to know which box to assign who and which box contains what. So that's why it's also important to give your variables or your containers a name. So I have a container. I want to define a variable here called A, and the value that I'm going to store in this particular container is 10. So A equals to 10, and let's say B equals to 5. But at the end of the day, I'm not defining or defining data just for the sake of it or looking at them. I want to do something with this. So I want to create a simple application or a simple program that can calculate the sum or add two numbers and give me the output, just like the same way you do with your computer. Somebody who built that computer started from here. So let's see if after this you'll be able to build your own computer, I mean your own calculator. So if I print that, you can see sum is 15. And of course, if you look at 10 plus 5, that is 15. So we started with variables. What we have here is actually an operator, and we call it arithmetic operator because it's something to do with mathematics and all that. So we have different types of operators. So let's look at operators. But before I do that, first of all, let's exhaust data types. So if you can remember, we say that data types, we have integer, we have float, we have Boolean. I also want to say that we have decimal. And if you talk about integers, these are whole numbers like 10, 1, 40. And we talk about float, these are numbers with decimal points. So the higher the decimal point, the same way the name changes. So if the decimal points are more, that is a floating point number. If it is less, then that becomes a decimal. So we can have something like 34.56. And then string, anything that is text is string. And normally when you define string, anything that is text appears within quotes. It can either be double quotes or single quotes. It can be H, can have something like that. If I say define 83 within quotes, it becomes string. When it comes to Boolean, we only have two options, true or false. But we have advanced data types that I was talking about, like lists. We have, so a list can contain one or two more, like even all the different data types that you know. I can have a string there. I can have a decimal number. I can have a floating point number. I can have actually a list inside a list. So you can have something like that. I can even have a dictionary within a list with key value pairs. I can even have a tuple within a list. So a list can contain any different types of data within it. So that's why we call them collections. And when we talk about dictionaries, you can see we have name and the value is John. And I remember explaining this, that the key is what matters. If I want to get to John, I need to know the key to getting to John. If I was looking for a word called zebra in the dictionary, I would start looking from the back because I know where Z is. Z is what is the pointer. It is the key to getting to zebra. So that is how dictionaries work. And then now that we have the different types of data, let's look at operators. So we have arithmetic. And arithmetic we have, so like what we've seen here, if you're adding two numbers like what I was doing up there, A plus B, that is addition. And then we have subtraction, A minus B. And then we have multiplication. In programming, multiplication becomes a star. So A star B means A times B. And then A slash B means A divided by B. And then we have percent. Now, if you want to find the remainder, when you divide two numbers, then you're going to find something called modulus. And modulus, the sign for modulus operator is percent. So if I divide A and B, modulus should give me the remainder. Just like if I say, let's say I want this. So what do you think will be the remainder if I divide A and B? What will be the remainder? Really quick. A modulus B. What do you think would be the answer? Simple arithmetic. If I divide 10 by 5, what is the remainder? Kennedy says 2. Where tafuta mwalimu wa maths. Faith. If I divide 10 by 5, what do I get? David says 0. Faith, what do you say? You can even type. Silo. Okay, can you explain why you're saying 0 and Kennedy says 2?
If you divide
Mhm.
10 by
Mm.
5,
Mm.
so 10 goes into 5 two times. So we have nothing remaining that you
Exactly.
can.
And modulus is going to just give us the remainder. And in this case, there is no remainder. So that's why you are getting 0. So I can change this to remainder. So that is what we print. So if you divide 10 by 5, you get 0 as the remainder. There is no remainder. So that is how modulus work. But what if, just what if? What will be the answer now? Kevin? Kevin and McKinney. What is the answer now? If I divide 10 by 3, what would be the answer? Ken. You're saying 1. All right, let's see. Tuone msema kweli hapa anasema nini? Exactly, now you got this right. The remainder will be 1 because you can go up to 9 and then the 1 that is now less than 3. So it's the remainder. All right. So I think get time and who can tell us which kind of operator is this? Mushaona. What about this? Now, if I divide 10, this also means division, but it means something also. So if I divide A, that is 10, by B, and it is double slash. Who can guess what the answer will be? Type mbio tukiona. Who can guess? Type 2. Sijawambia hata ongea. What do you think? 10 divided by 3, but it is double slash. I mean, just type. Just type. I'll give you the right answer and I'll explain why. And you might even be right. I'm expecting answers, whether they are wrong or right. Come on, guys, I'm waiting. It's a simple thing. If I divide 10 by 3, but it is double slash, give me what you think. What do you think is going to be the answer? Just type. Kennedy says 1.5. What are the others saying? David says 3. What is Faith saying? What is this? Amisi? I don't know. So somebody. All right. So the double slash actually means divide A by V by B, I mean, but round off the answer to the nearest whole number. In case there is a decimal number, round it off to the nearest whole number. So before I give you the answer, what do you think is going to be the answer now? Divide 10 by 3, round off to the nearest whole number. Okay, watu wa hesabu. Haya, wacha tufinye msema kweli. So actually the answer is 3. And the reason why the answer is 3, let's first of all divide it the normal way. So we get 3.3. If you round off this to the nearest whole number, you're going to narrow down to the number that is closest to, which is 3. If it was 3.6, it will go to 4. So let's see, something like 7. So I guess 2.33. I wanted something a bit. Let's give 13. That gives me 4. Why am I unlucky? Can somebody give me a number which will give me 2.6 or 3.6 or 3.5, something like that? Let me try 31. 10.3. Come on. 35. All right. That gives me 11.66. So let me do the double slash. And let's see. So now it rounds off. It's like what we're calling truncate. Round off with the nearest whole number. So we are in 11. The nearest whole number that we have there is truncate and give me 11. So that is what it does. And we've already seen this. If you wanted to find the exponential of a number or square a number, you do the double stack. So that means a squared would be a star star a. So let's try that with this. Let's try to square a. And let's give it a number that we all know. So that gives me 4. Is that true? The square of 2 is 4. So if you want to, so I think let's move to the next type of operators. So we have equal to, and somebody asked me this. I don't know whether they're here today. And then we'll move to logical operators. And then assignment. Let me just do this, and then we can. We have Bitwise. Okay, I think then we have membership. Then we have identity. So you just want to explain them really quick. I think that is the last of what we are going to do about operators. I know you didn't know there exist so many operators like this. Even if you look at your calculator or your scientific calculator, you don't have that much operators. But when you start thinking like a software engineer or like a programmer, you realize that there is more to maths, or there is more to statistics than what you know or what you've been taught so far. So when you do programming, normally they say somehow it opens like a third door in your mind and you think differently. And it expands your thinking a bit because you get to explore data in details, and you get to manipulate, engineer, and do a lot of things. Let's move to comparison operators. So we have equal to, and this is the double equal sign. Remember, what we have here is what we call assignment. You assign the value to A, and this is an equivalent of doing what? Declaring a container called A and putting a value called 2 inside it. And that is what we call assigning a value to a variable. So a single equal sign means assign the value, a particular value to a variable. But when we look at the double equal sign, it means comparison. You are trying to find out if the value of A is actually equal to the value of B. That is comparison. That is no longer assigning A to B. But if I say A equals to B equals to 2, can somebody tell me if I print B, what will I get? Or A times B? What will be the answer of A exponents B? A equals to B equals to 2. Trial? for faith okay, nimeamua copy sawa. Actually yes, because we are saying assign the value of b, which is 2 to a. So if we say a equals to b, whatever is stored in b will also be stored in a, and b equals to 2. So meaning the value that is stored in b is 2, but this value that is stored in b is also stored in a, and it is passed from b. So that is like calling somebody the same person with different names. It's still the same person. Okay, so I hope we understand assignment operators. But how do I check if something is not equal to something? Now you introduce exclamation. So not equal to. So if A is not equal to B, or you're trying to check if A is not equal to B, then you're going to use A exclamation equal to B. Now there's even something funnier that I can do. There's a way you can do a short form of these operations. Let me just comment this out so that when you see it one day, you're not confused. I want to do short form, and you can apply it to any other operator that you know. Short form of A equals to A plus 5. Sorry, plus. So short form for A equals to A plus 5. So let's say we had A up here. So I want to say A equals to A plus 5, but short form. I don't want to go into that, writing A twice. So I would say A, because I'm adding A to something, I would say A plus equals to 5. So this plus here actually translates, because it is the same A, it translates to the longer form of A equals to A plus 5. You can apply this for multiplication. You can apply it for division. You can apply it for double division or modulus, whatever operator you can do with this in arithmetic operators, of course. You can do the short form so that if you want to program or code differently, look different from the others, or a bit pro, don't do A equals to A plus 5. Just do A plus equals to 5, and that should give you the same answer as if the value of A is 2, there it should give you 7. All right, so let's test this out. So probably we're going to use if statements. We learned about Python syntax, so this should not be a problem. So I'm saying if A equals to B, then print A equals to B. And you can see here that we are printing nothing because A is actually not equal to B. So the only thing, okay, let's do that now. What do you think will be printed? Mio, what do you think will be printed? Now, I've said A is not equal to B. What do you think will be printed? Just unmute. Unmute and just speak. What will be printed? I'm saying if A is not equal to B, print A is not equal to B. So what do you think will be printed? Will it print something? Will it print something, yes or no?
Yes, it will print that statement. A is
Exactly.
not equal to B.
Exactly. So we are using this operator, not equal, which is true. A is not equal to B. Now, greater than, this is so direct. Use the greater than sign. Nakuweka ka elbow kidogo. If you're on my left, pia nakuweka ka elbow kidogo. But this is so direct. A is greater than B. So you can check. You can mostly we use them in conditional statements like if statements. So maybe to check. And then we have, who can tell me this in full? It's already there. You've seen. So we have greater than or equal to. A is greater than or equal to B, and we have A is less than or equal to B. I think if you've done normal arithmetics or math or statistics, this is so direct. You don't need to explain anything there. Now, then we have logical operators. The logical and the we have and, we have or, and this one, if you've done statistics, this is something that you should be aware of. So we have not. These are logical operators. You can say A and B, or A but not B, or not A. Whatever you say, you are logically reasoning. So we can say if A is greater than B and B is greater than 1, then print both conditions are true. So the AND here, when it comes to programming, the AND here is, let me say, the AND here means the condition on the left-hand side and the condition on the right-hand side must be true for whatever is within this if block to be executed. So this one must resolve to true. This one must resolve to true. That is what you should know about the AND operator, and we are all done. So if either of them is false, nothing will be printed. So if you are writing an application that has to check multiple conditions, more than one, and you only want to execute if the username is okay and the password is okay. Imagine a scenario where you're logging into a system, you only know my username, but you don't know my password, because that authentication system was loosely programmed. It used or instead of and. Imagine if you have my email or my username, you could be able to log into my email, because if my email is right, it doesn't matter whether my password is wrong. So that is how critical it is in real world. So we can also use or. And or, what you need to know is that if either of the sides is true, it will always print. It will always resolve to true. One true cancels out all negatives. So all we need is for one side to be true, whether it is on the left side or on the right side. And then we go ahead and execute the code block. So that is what you should know about and or. And then we have not. So we have so let's say if you have a scenario like if, let's say we have something like that. Now we're expanding. If not A equals to B, what does that resolve to on this side? Somebody tell me true or false. If not A equals to B, what does that resolve to? I think I need to show you B again. A and B are all equal to 2. But remember, at some point, I'm modifying the value of A. So I want to just show you the new values of A and B. So just print A and also print B. And then comment this out so that you see the answer. So A is 7. Why do we say A is 7? We actually increase the value of A by 5, because here A was 2. When you come here down with that 2, we are adding 5. That gives you 7. So that's why we have A as 7, B as still 2. We didn't modify the value of B. Now that you have this, what do you think this gives you? Let's do it step by step. If not A equals to B, so you're checking here if A equals to B. So let's deal with the left side kwanza. And remember, the operator in between, separating the left and the right, is and. And then you'll be able to tell me whether this is going to be printed or not. So let's start with this, step by step. On my left, what do you think it resolves to? A true or a false? Yes? If it is a true, just type there true. Said says it is a false. Anybody else? Faith says it is a true. Kennedy says it is a false. Now I want us to reason together. Let's start with in your knowledge of mathematics. You know that if you see a bracket, you start with resolving what is in the bracket first, right? So let's start with what is in the bracket. What does this resolve to? Hamisi? A equals to B resolves to what? Is A equal to B? Hamisi, tunatafuta answer. Jibu tu.
No, A is equal to 7 and B is equal to 2. So
They are not equal. So this gives you a false, right?
Yes.
Now, in common English, if I'm negating something, I'll use not. Not me, not you, not her, not him, meaning I'm negating, right? Now, what is the negative of a false, or what is the inverse or the opposite of a false? Because not normally negates everything. So if this is positive, it negates. Now, if what we have here is false and we have not outside, what does it become?
Becomes
What does all of this become?
It becomes true.
It becomes true. So I think Faith is right, and it has been proven. Wewe unaandika true hapa tukishasema, alafu hakuna bwana. So that resolves to a true. Now we have the left side resolving to a true. Now we have one thing that we also need to understand. We have a true on the left side, but the operator that we have here that is separating left and right is and that so we need to start by resolving this. Is A greater than B? A yes or no? Really quick.
Yes.
A yes. Is B less than A?
Yes.
So the whole of this bracket resolves to true or false?
True.
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 So we have this side and we have this side. Now I want somebody to tell me what will be printed on my terminal if I run this code. Faith. What will be printed? Just say it. If it is nothing, just tell me nothing. If it is whatever, tell me whatever will be printed. Who is saying whatever? Nitafukuza huyu hapa. Yani nimesema whatever, unasema whatever. What will be printed? Thank you. Sasa wacha tuende kwa msema kweli. Actually, it prints that both conditions are true. And we've seen how to actually analyze and get into the root of trying to understand how these operators work. I know logical operators can be a bit challenging. That's why I had to go in depth to explain. I've already discussed this. Remember when I told you the short form of A equals to A plus B, or A equals to A plus 5 is simply A plus equals to. That is what we are doing here, assignment. And I also said single equal sign means assignment. So this one is under assignment because we are assigning and increasing or changing the value at the same time. What we are doing here. It's like we are assigning 5 to A, but we find that A already has a value. So meaning the plus sign here is going to add before assigning. So when you add the value that already exists in A before assigning, you get 7 that you assign to A. Same to minus. I want to minus before or subtract before I assign. So whatever is in A, you minus with whichever value is on the other side of the equal sign before you assign it. Same to multiplication and I think I showed you all this. Then we have bitwise. Now bitwise is like the binary or the bitwise. Oh, I'm explaining a word using a word. If I talk binary, this is like binary. And when I say binary, binary operates in bits, and bits, as we know it, bits are always in zeros and ones. It's either a 0 or a 1. So if I have A and B, what does that mean? And here resolves to a bitwise operator, which is 1. So it is like the AND here, but the only thing is that this is a logical operator, but this is the bitwise form of it. So they should work the same way, but this one is majorly used in databases. But this one is majorly used in business logic. You're writing logic like, login logic or something like that. And then the same with this. When you are querying, there's a language called structured query language that is used to interact with databases. So you find that you can't use and what we're seeing here in database queries. So you're using the bitwise form of things, but they work the same way. This is the bitwise form of OR, and this is the bitwise form of NOT. And then we have the exclusive OR, where you exclusively check the value. Then we have left shift. So these was our advanced bitwise operators. You don't need to know about them today, but as you advance, you can you will be able to learn about them and how to apply them. And then we have membership. Now this has become interesting. So we say, let's say I have I have a list. Let's say somebody give me a list of fruits, of your best fruits. Just unmute. Uniambie. So I want to define ishaiba answer. So I have I know there are people here who can sleep without taking a bite of a banana or a cherry. Or maybe an apple. So let's say we have a list of fruits. So, or think of it as fruits is the name of the container that stores this collection of items that you have defined here, which you're calling a list. And the only way you know this is a list, if you see square brackets, that's a list. Or you can also define a list like this using the list keyword. So I can have apple, banana. I can do it that way. But, or I can initialize an empty list like this, and then I can assign values to it. So that is an empty list, and then I can say fruits dot append apple dot append banana dot append cherry. So if you want to add items to a list, you actually append. So you say this is the container. So try to append apple. Try to append banana, try to append cherry. Because it is a list, it's going to append these values. And if I can actually print this out, we print fruits, you'll be able to see that we have a list. And how is it normally printed out? In square brackets. So if you see square brackets, just know that is a list. Now, I want to explain how we bring complex data types or collections into membership operations. Now, let's say you are looking for, you're logged into a system and you are searching for a faith, or you're searching for this guy called a Kennedy inside that system. So you go to the search bar and you type Kennedy. So what happens is you're filtering through a list of items that exist in that particular database. And if it is found what you're looking for, it's going to give you that particular result. So we can actually write code that sits behind what you normally see. You normally go to Google and type something and search, but you don't know what sits, the logic that sits behind that that particular field that you type and submit. When you type and submit, what happens then? Something like this happens. So I could say for fruit in fruits, and then I can use an if statement. So I'll go inside this and say, if fruit equals to banana, then print yellow fruit found and the fruit name. So what I'm doing here is once I have my list of apple, banana, blah, blah, blah. So I have what we call membership operators, and the membership operators allows you to look through different items or a collection of items or a list or a dictionary, whichever. so long as it is something that you can look through. And then you can do operations with whatever values are in that particular collection or list. So here you have my fruits, banana, and cherry, and apple. So I'm actually visiting each item one by one, apple, banana, looking for a fruit whose name equals to banana. The same way you go to Google and search banana, and I go to Google and search banana, it's going to look for what is available about bananas in the internet and return some results to you. So we are doing that here. Now, if I print this, so this is going to loop until it finds an item called banana. And I can show you this in real time, how it's happening. You see here that if you open your VS Code and you just behind the numbers, if you take your cursor just behind the numbers, you see there is a red ball. So you click on that red ball, your code will, when your compiler is running this code, it will stop at that particular checkpoint. These are like checkpoints to show what value is that at that particular point when it is running, and how you'll be able to see how the loop is running actually. So if you come here, you're going to now do it differently. You click on this drop down and say debug Python file, so that you're able to see. Debugging actually means you're able to open the process and see how the application actually runs. So then I can click on run debug. It's going to ask you Python debugger, blah, blah. Just click Python debugger and then say you're debugging a Python file. So it's going to load, and you can see it has loaded. On this left panel here, you're able to see your local variables, and you have the variables that were declared here, a equals to 7 and b equals to 2. Actually, the values have been printed out. And then we have fruits, which has, you can see it has apple, banana, cherry. And that is what has been highlighted here. If I take my cursor to fruits here, you can see we have at index 0. In a list, it starts counting indexes or the positions of the items from 0. So at position 0, we have apple. And the last position, position 2, we have cherry. So what happens here, it's going to loop through looking for banana. So it goes inside the loop. That's why we are calling it a for loop. It's going to, it allows you to loop through items. So it goes inside and goes to the if statement. Now, at this particular point, remember it is looping through each of these fruits from index 0. So the first one, in the first loop or the first run, we have the value of fruit to be apple at index 0. That's why I was showing you this. And that is why I was showing you fruits and how they have been positioned. So we have 0, 1. So meaning the first round of runs, we are going to start with index 0. So here the value of fruit is apple, and you can be able to see it is apple. Now it's going to check, is apple equals to banana? So at this particular point in this if statement, what is passed here is apple. Is apple equal to banana? No. So what happens? It goes to the next item. So if I just click on this to move to the next item, you can see it goes back to loop again. And now let's check the value of fruit here when we run it again. So let me run it. And you can see now the value is banana. It is at index 1. And then let me run it. And now you can see that it goes to the print statement on line 65 because this resolves to true. And if I run it, and now you can see that we have, well, let me just print this out. So we have banana, and you can see yellow fruit found, banana. So when fruit equals to banana, or the index is found, it's actually giving you result. And that is the basic logic on how search fields work, or maybe whatever you search on Google works. And it all makes use of the membership operator. So I could say if not And I said not negates everything. If not fruit equals to banana, then say yellow fruit not found. So let me run it and see what it prints. So you can see whenever the fruit here is not banana, it's going to print. And what index was that? We can try to run it again and see which item exactly. So we have, at this point, we have apple equals to banana, but not negates. This particular section here that I've highlighted here actually resolves to, you need to know first before you negate. Apple is not equal to banana, so that resolves to false. But when you negate it, it resolves to what? True. And if it is true, it will always execute the code inside the if block. And you can see that was done. And it goes back, it checks for the next item in the list. All right, so I'm done with operators. We have identity operators where you check if A is B, A is not B, things like that. You can try this out, but I think we are done with operators, unless if you want to dive deeper. So now let's, I want to give you one thing to do. And I'm going to, actually, I wanted to, before I give you something to do, I wanted, if you did the assignment, just quickly share your screen so that you can share what you did. But probably we are ending our class today here. Yes, Faith?